channel Learn SQL with Shahid. In last class we are discussing about this in-row data, row overflow data, LOB data. So I will be discussing today about this GAM and SGAM. So that let us discuss what we have discussed yesterday. In last class, like we have discussed like row in-row data. So what it does means like 31 row it should fit into that one page capacity, that is 8 KB, which is 8060 actual data. So one row has 258 byte, 8060 divided by 258 means 31 row capacity. It will fit inside, okay, inside 1 MB data. So if you take 5 MB data, then it will fit 19,840 rows inside 860 pages, okay. And also I have discussed this carry is 8000, it is limit up to that, and maximum length of var is var max. And if row overflow, in case of row overflow data, if we have a larger column has var of max, if it is exceeding above 8060 data, okay, 8060 bytes, okay, so then it is pointing towards to large update page. That if it is more than 8060, then the data will move to large update data here, and 24 byte pointer will be maintained to actual data, okay. So if from here to here 24 byte pointer will be maintained. Why it is maintained means it is row overflowing, right? So it has to go to large update. It won't support here. So whenever it is getting less, someone has get updated, then it will come back to its original position. It is that also we have this image in case images some small videos. So okay, if it is that case, we have to enable file stream. Okay, I showed you during the installation we had to enable file stream, then only that image and videos will be supported to that. So again that thing goes to that video and images goes to LOB data. So these things and all I have discussed in my last class. So in row data, row overflow data, LOB. So I am going to discuss I also have discussed this page free space. We simply can understand it contains information about the pages, okay, 8088 pages, that is nearly equal to 64 MB data, okay, 64 MB data or else 8088 pages. If we calculate this in 64 MB, it supports 8088 pages, okay. Here is the maths. 1 MB page means 128 pages, so 8088 pages divided by 128 is equal to 64 MB. Or else we can do this maths also. 8088 pages, one PFS contains 8088 pages, so into 8 KB, one page capacity is 8 KB. So if I multiply by 8 KB means then it comes some value, and divided by 1024 KB means 64 MB. That also you can, if it is whether this or this, I can go and calculate, okay. So like one page free space, for example, I have given this is one interval. If 8088 pages complete, then again 8088 pages will allocate. Again it allocates 8088, then again it will give the 8088 pages. And also I was discussing about this GAM and SGAM, okay, yesterday, like in last video. So what is we have to know what is extents, okay. Extents, what is extents? Collection of 8 contiguous pages is called extent. One page capacity is 8 KB, so collection of 8 pages, 8 into 8 means 64 KB. This means for database for per MB data, per MB data we have 16 extents here. Means I said for 1 MB we can have 128 pages. 128 pages divided by 8, so we'll get 16 extent, okay. So SQL Server has two types of extent. First one is uniform extent, second one is mixed extent, okay. Uniform extent means it is the single object. All 8 pages in the extent can be only be used by the owning object. This means like we have object means tables. Okay, so table one is in the extent. In one extent, we have 8 pages, right? All the pages. Table one is owning. Okay, so table 1, table 1, table 1, table 1, table 1, all the pages is owning by table 1. So it is in mixed extent. So it is uniform extent. If it is mixed extent means we have table 1, index 1. This also we can consider it as a data page. Okay, index 1. How it is stored and all, I will be discussing that in future classes. So if you have table 1, table 2, table 3, table 4, again table 1, table 2, table 3, like that, that is known as mixed extents. Mixed extents are shared by 8 objects. Okay, 8 different objects you can say, like table 1, table 2, table 3. Each of the 8 object pages in the extent can be owned by a different object. That is only different object means different tables can be owned by. In simple I will be explaining you hope this one you will get clarified. So if I have this extent, right, you have 8 pages in one extent. So what here I have table 1 is object, table 1 is there, no, and page 1 it is occupying. Okay, and page 2 table 2 is occupying. Okay, in page 3 table 3 is occupying, table 3. In page 4 table 4 is occupying. So why initially whenever the table is created on the database, okay, so initially the SQL Server won't give the whole extents to table 1 initially. So why this means SQL Server engine does this internal operations and it don't want to waste any space inside that. So it has to prove like we have table 1, table 2, these different subjects are occupying these objects on the pages, right? So table 1, table 2 is occupying on pages. So it has to prove again if it is a table 1, here table 1, table 2, table 3, table 4, again table 1 is occupying on page 5, table 1 is occupying on page 6, table 1 is occupying on page 7, table 1 is occupying on page 8 also. So from next onwards, like SQL Server, it has to SQL Server, it has proven that table 1 object is randomly growing. Okay, so from next extent it will give for table 1 objects. Okay, table 1 that every page in the extent will be occupying by this table 1 only, t1, t1, t1 means see it has maturity that it is growing again and again, SQL Server itself detects. Okay, and gives extent. Okay, whenever we create table on database, right, tables will ask for extent, not for pages. If we table 1, table 2 different objects have been created and in a extent on the pages, so it has to prove first. It has proven, table 1 has proven now, so it is giving the whole extent for table 1 like this. So this is uniform extent, this is mixed extent because we have different objects t1, t2, t3, t4, t1, 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 again it has grown, so it has given the whole extent to the table 1 here. So you hope you might have understood this concept, a simple concept, but initially it will be difficult to understand. So I have given this example to better understanding. Now if we go to GAM and SGAM, you will be very comfortable to understand. Okay, so GAM means global allocation map, SGAM means shared global allocation map. it has information about whether extents are allocated. Okay. SQL Server uses two types of allocation maps to record the allocation of extent, that is GAM and SGAM. GAM, so GAM pages records what extent has been allocated. Okay, means what extents has been allocated, and each GAM covers 64 extents. For example, or almost 4 GB of data. Almost 4 GB of data means one GAM interval is 64 extents. Okay, 64,000 extents are almost 4 GB of data. That means, like in page free space also I have explained, one page free space page has 8088 pages interval. Here that is for pages. Okay, this remaining SGAM, SGAM, IAM, DCM, BCM and all has extent. Okay, extent, it gives the story about extents, that gives PFS gives the story about the page. This is all the main important thing to be note down. So we have 64,000 extents. Okay, 4 GB means if for example, if we take the calculator here, how much MB 4 into, you have to convert this into MB. Okay, 024 is equal to, we have 4096 MB here. Again, for 1 MB, we will be 1 MB data, we will be having 16 extents. So like 4096 MB into 16 extents. Okay, so we'll be having 65,536 extent. That is the GAM interval. Okay, so that is the thing I wanted to explain here, are almost 4 GB. Same, I have calculated 4 into 1024 again into 16. Okay, 1 MB means 16 extent. So we have around 64,000 extents, one interval, for one interval, or 4 GB of data. If the GAM has 1 bit, okay, for each extent in the interval, if the bit is 1, okay, if the bit is 1 means the extent is free. We have in SQL Server database internals, it will you have bits. Okay, 1 means it is free. If the bit is 0 means the extent is allocated. So this GAM internal has 1010. So this SQL can understand this language 1010. SGAM records which extents are currently being used as a mixed extents, and also have at least one unused page. Each SGAM covers 64,000 extents. Okay, as same like GAM, it also covers 64,000 extents, or almost 4 GB of data. As I explained in GAM example, we have 4 GB of data. We have to convert that into MB 1024, then 4096 we have, and 1 MB means 1 MB data we can store 16 extents. Into 16 means 65,000 we got, no, nearly equal to same thing, like 64 extents we have, or almost we can say 4 GB of data. This is 64,000 extent is GAM and SGAM both 64,000 extents is the interval. Okay, we can say one GAM or SGAM interval. The SGAM has 1 bit for each extent. In the interval it covers, if the bit is 1, the extent is being used, okay, as a mixed extent, and has a freeze page. If the bit is 0, the extent or it is mixed extent, and all its pages are being used, extent is not used as mixed. So this means see, now I will be explaining GAM bit setting and SGAM bit setting here. Mixed extent with free pages I will be explaining. If GAM is bit is setting is 0 here, okay. If it is mixed with free pages, okay, free pages, then SGAM is 1. This means if I go here, consider this one extent, okay, leave this remaining everything. this GAM and SGAM I am explaining here. In this extent, for example, table with 1, okay. If it is consuming, here GAM means, see here, in this table 1 is occupied, remaining 7 are free, okay, in one extent. Page 1 has a, page 1, table 1 is occupying. So remaining 7 pages are free. So it is, we can say this as 0. Here 0. And if it is free, here you can observe. Here you can observe mixed extent, okay, whatever it is, mixed extent, one free space left or 7 pages free space left. Here 1 it will be, okay. If it is mixed or uniform extent, doesn't matter. If one is occupied, one page is occupied in the extent, then GAM is 0. SGAM is then the remaining pages are left free. So we will be having 0 1 combination here. That is what I have explained here. Okay, one page left free means, if I have again here T2, it is mixed, okay. T2, T3, T4, again here T5, T5, T6, again here T1 is occupying on page 7, T1 is occupying on page 8, okay. This is mixed extent, okay. Now for example, if I control Z, if I don't have here, okay, one page free space left in a extent, then it is also 0 1 combination, okay. So 0 1 combination we have GAM 0, one page free left is 1, SGAM means 1 here. So if it occupies again here, if it is mixed or uniform also, it doesn't matter. If one page is left free, then we have 1 here. If and allocated means GAM means it will come 0. Everything is now filled up with mixed extent here. So what this means, if it is mixed or uniform extent here, see here, then it will become 0 here. Here also 0, 0 into 0, like that, okay. 0 into 0 combination, okay. That is known as 0 into 0 bit allocation, okay. So again we have free not being used. If here again we will consider it is free, okay, and it is not being consumed means, then it is GAM will be 1, okay. Here for this example, GAM will be 1, not being used means will be giving 0 SGAM here, 1 0 combination. So if it fills here something with T1 again, then 0 1 combination. If everything is filled, 0 into 0 combination. If nothing is there, like this means GAM is extent is free. So 1 0 combination, like that. Hope you have been understood this concept. So nothing to worry about this. Like you can say in your interview, GAM will tell the information about the extent, whether it is free or allocated, okay. SGAM means it will tell the story about the extent, whether it is mixed extent or uniform extent. This is the simple definition for GAM and SGAM. You can say these things and all what I have discussed for discuss it because of our understanding purpose. Okay, again if you want I can go here, I can show you. Again see here, if nothing is there, then 1 0 combination. If it is for 1 0 combination, if everything is allocated, the 0 into 0 combination. If if some pages are free here, then it is 0 1 combination. GAM is 0 allocated, and 1 SGAM means remaining free. Same thing I have explained here also. You can take the screenshot of it, and you can also explore about that. And next is IAM, index allocation map. Okay, so same thing, like it tells the story about 4 GB chunks only. Like it will tell the story about the pages or index. Okay, and it is that 4 GB chunks is called as IAM interval. Okay, whatever 4 GB, after filling 4 GB again 4 GB, it tells the information about the tables present in the pages. Okay, for every 4 GB, one IAM page. Okay, one IAM page means that interval 4 GB is the interval. So we are having in row data here. We can table or index, I said, as it tells the story about the table or index. We have partition here in row or flow data and LOB data. So in row data means IAM page, each page can hold a 4 GB allocation unit information, and IAM page here. So here in this example, IAM page, okay, it can be stored, it goes to non-clustered. I will be discussing these things, what is non-clustered index, clustered index, and all. That is, actually it comes in level 3 topics. So I will be discussing that, these things and all. So here, what is that thing I want to explain here means, in IAM page, right? So we are creating a table on the pages, right? These are the data pages. Means in this case, non means like whatever we creating, right? R1, R2, R3. It will not be in. It is not necessary to be in random order, like R1, R2, R3. It is properly arranged like that. It can be random also, R1, R21, R4, R16, R8, R18. Same thing in second. Okay, after this page, second data page, like R2, R3, like it is pointing towards the links. Okay, the data page, again next data page, like that. So what is this thing and all, I will be discussing in non-clustered index. I will show you like the data page opening in level 3 topics. So that is the thing I want to explain. Like again I will once again go through this. Like IAM page means it tells the story about the tables or index pages, and one IAM interval is 4 GB chunks. Okay, so that you can tell in the interview. And also I will be discussing about DCM pages, differential changed map. Like it tracks the extent that have changed since last backup. I will be discussing this in full backup, everything. What this means like DCM pages we are having, right? Like we are taking the full backup. For the example, full backup is taking on Sunday. Okay, Monday, Sunday to Sunday full backup we are taking. On Monday, whatever we take the full differential backup, right? In the differential it modifies the DCM pages. Okay, whatever the data changes, insert, update, delete, whatever we do that operations, it is tracked by DCM pages. If DCM pages is not there, then there is no differential backup. We are having different types of backup, the full backup, differential backup, T-log backup. So that and all I will be discussing in backup topics, so you can understand now. Like it has also 10 bit, 1001 something like that allocations. Okay, so it also if some page is getting modified, like insert, they are inserting, that is also modifying. They are updating some data, changing salary to 20 to 40,000. So again that is also one change. Whatever the data it is modifying, it tracks the that data with DCM page, okay, differential changed map, since the last backup. We can take the differential backup on that, so it helps to take differential backup. So that is the thing. I will be explaining this BCM bulk changed map, okay, in my next video. So because it needs a long explanation, so I will go through a quick overview what we have discussed, like here, like page free space tells the information about the pages, okay, 8088 pages, okay, page free space tells about, and it tells the information how much page is free and how much it is allocated, okay. It tells the story about 8088 pages. One PFS interval is 8088 pages, or nearly equal to 64 MB of data, okay. So we have this page free space, still 8088 pages. Next interval, again it carries on for 8088 pages. SGAM means you can tell simply like GAM. SGAM means, it tells the whether the page is allocated, that is 0. If the page is free, that is bit 1. So simple, you can tell this thing. And SGAM means I tell the information about whether the extent is free or extent is uniform, okay. So you can tell this thing in interview. And also IAM page means it tells the story about the table or index, tables present in the pages, okay, and or index. And one IAM interval is 4 GB. And DCM means whenever we take differential backup, at that time whatever the data changes are there, no, which are modified, the DCM pages will be track that extents, okay. So that's all for today's class. I will be discussing this BCM page, and I will be going to this log file architecture as well in my next video. If you like this video, please share, subscribe to my channel. Yeah, thank you guys. Take care. Bye.